that does not conserve energy, so non-conservative work is equal to the change in the total energy. That capital E there is the total energy, that's kinetic plus potential. And then conservative work is equal to the negative change in potential energy. Now, work in general is equal to force times displacement. I can figure out how much work was applied. If I take this marker right here and I drop it, as it is falling, what forces are acting on it? See, people are still writing down. Let's take a dramatic pause here. We'll wrap this up soon. I take the marker and I drop it. What are the forces acting on it?
Wait.
Okay? Is that a conservative force or non-conservative force?
Conservative.
All right. So, let's say it fell 2 meters. So the weight of that object, mass of, let's just say 0.1 kilograms, probably still too high, times 9.8 meters per second squared. That is the force acting on it, times 2 meters. Doing the fancy math there, 1.96. The Earth did 1.96 joules on this as it fell. I now take this marker and I throw it up into the air. After it's left my hand, what are all the forces acting on it?
Normal force? Normal force?
What's it touching?
Oh, that's right.
Wait.
All right, we got weight. Anything else?
No, it's fine. The force you use to push it
Is
up.
it air resistance?
Oh, you want to bring too much reality into it. The air resistance doesn't exist.
We can ignore that.
Yes, it does, but that, well, I don't want to complicate it that much. What would be the other? After it's left my hand, I have Jedi powers. You could have said, yes, you have Jedi powers. I believe you are a Jedi master. You're not going to go that far. Once it leaves my hand, I have no more influence on it of any appreciable value. So if I take this marker and I throw it up into the air, let's say I throw it up into the air 2 meters, what's the amount of work I did then? Well, this dot right here is a little bit more meaning than just straight up multiplication. If the force and displacement are in the same direction, like when I dropped it, I end up with a positive answer. If they're opposite each other, it's a negative. So if I mentioned up was positive, well, that's positive 2 meters, but the force is down, that's negative, whatever, 0.98 newtons. So as it fell that way, it was positive 1.96. As it goes up, it would be negative 0.9. Let's assume up is positive. Negative 0.98 newtons times positive 2 meters, which is negative 1.96 Newton meters or joule. If the force helps the movement, it is positive work being done. If the force hurts the movement, it is negative work being done. If the force is perpendicular to the movement, no work is done.
So work only goes like up and down? Right?
No, it's the direction of force. So, for example, I have a mass here, I'm going to push it across the table. There are 3 forces acting on it. Normal force from my hand, the weight of the weight pulling down, and then the normal force from the desk. I do work on it because the force I do positive work because the force I applied is in the direction of movement. The weight does no work at all. The normal force from the table does no work, because it does not move up or down. It's only the forces in the direction of movement, or that have any part in the direction of movement, that can do any work. If it's coming towards me, and then I use my hand to stop it, I'm doing negative force. Another way of looking at it, kinetic energy is related to how fast it's going. If I slow it down, my change in kinetic energy is negative. My work is negative. If I speed it up, I'm going positive force. So in the lab, you're going to be dealing with what's called Atwood's machine. You'll have an object falling and another object rising. The one that's falling has positive work being done to it. The one that's rising will have negative work being done to it. And that is where we will end it. We're going to mosey down to the other room. We can unlock it, and I need to turn on the light. Oh, and handing stuff back. Get it? Let me get stuff back, and then if you've got time. All right, so we're handing several things. Well, for some of you, handing several things back. Linear motion labs and handing back now. These are the ones that were done on paper. Because I think for the linear motion lab, I did the ones on paper, I've not done the ones, the electronic ones yet. I would expect two. Oh, I don't think I put this in actually yet, because I haven't done the others. So. Little arrow. Orange. All right, and now the test. Oh, I should have turned this off. I don't think I flashed the grade in front of it.